I'm joined today by Maor Farid, co-founder and CEO at Leo AI, whose team has built an AI tool specifically for mechanical engineers. Now, Leo is powered by a patented large mechanical model, LMM, and this is a CAD-Aware AI trained on customer-specific models and documentation, as well as more than 1 million vetted engineering sources. Mo, welcome. I'm so excited to learn from you what it is that you have developed.
First of all, thank you so much for having me, Rihanna. It's a pleasure talking to you. So maybe before I'm going to share exactly what we're building, I'm going to share with you why we're building. This is basically what we do. We unlock your PLM knowledge in order to allow you to stay ahead and to provide a competitive advantage to the firms that we're serving. So what really is the problem in mechanical design, right? We're doing a lot of things. There are a lot of problems along our process, but what really is broken? So the problem is that not that SolidWorks is not great, not that Onshape is not great, but the fact that in 2025, our knowledge, the tremendous amount of knowledge in the organizational databases is huge, but it's still siloed. It's locked in the brains of the older mechanical engineers, the later career, I mean, those that are for ages in the company. It's locked in the mountains of documents that the organization created in the last 2, 3, 7, 10 decades. And it's locked also in the mountains of CAD files that they designed. So a lot of the information is not written in text anywhere. You need to open Onshape and measure it there. For example, if you want to see what's the minimal thickness of the hull of the battleship that you designed in 1995, it's not written in any PDF document. You need to open Onshape or SolidWorks and measure it. And also in the Bibles of engineering, right? The Shigli, the Incoperas, the MIL standards, the ISO standards, the knowledge is there, but we cannot really access it. And in the money time, us engineers, we just have no other choice other than reinventing the wheel. So what is the result? And engineers could sympathize with it. This is, in the meantime, when I say it, this is a video of it's a screen recording of a mechanical engineer with 10 years of experience trying to add just one spring to a dashpot, right, to a suspension system. Even though the spring was existing in his PLM, he cannot find it here. And he's going through hours and hours trying to find it because he cannot access the organizational knowledge and the vendor parts and his PLM data. So organizations are spending something like 40% of the time on reinventing the wheel, which is finding parts on vendor catalogs or in my PLM or writing documents, making decisions that were already made. And 40% of the time to market is derived from this, and 1/4 of the product life cycle costs. So we just build the first AI model, as far as we know, that can understand CAD, not only text, but and not only images of CAD, but real CAD, the BREP, the representation of the CAD parts and assemblies. It was trained on over 1 million Bibles of engineering and 120 million vendor parts, and it's connected into the organization's knowledge bases, their PLM, different Windows directories, etc. And in this way, it basically can answer any question on your data, answer technical questions, and find you the best fit parts, and everything in enterprise-grade security. Of course, all the data is protected. And this is what we're striving to and guarantee to our customers, the immediate ROI. According to our data, this is the performances that we were able, or the benefits that we were able to unlock for our customers. According to the averages for our customers, we were able to save about a third of their redundant design, tasks, and time, reduce the design errors in 30%. And you know what could be a cost of a design mistakes? It could be something of like $10,000 to millions of dollars. And also to accelerate the TTM dramatically. Yeah, and save something like 5 hours per engineer per week. And this is the average. For some, we save 80% of the time. But to be conservative, this is the average. And we're proudly serving some of the world's leading engineering companies. And we're serving basically as their AI trusted partner, like Intel, Scania, HP, and many more. This is the underlying technology, the 3 patents that we have, and this is the LMM, the world first AI model that can understand CAD. Unlike ChatGPT, which is a large language model that can understand text or language, we understand mechanical parts as well. Why not ChatGPT? And this is, a funny thing. When we talk to engineers, they're telling us that they hate ChatGPT and even prefer Google because Google is not lying, it's not hallucinating. But ChatGPT is lying very frequently, something like 40% of the time for mechanical engineering questions, almost a half. And this is the reason. This is the breakdown of sources behind the scenes of ChatGPT. 40% comes from Reddit. And if you're thinking about it, this is exactly the opposite of how us humans developed the thing called engineering. It was an art going from father to son. And in the last centuries, it's coming from a standard or a book to son to an engineer. Reddit is the opposite. It's anonymous people from around the world, saying things that are not reliable, and you're doing a lot of mistakes based on it. ChatGPT engineering tools are not CAD-aware, not integrated to our workflows, and cannot understand CAD, and of course, not accurate. So what you see here is a screen recording of how Leo is assisting in real time to mechanical engineers. In this case, we see a mechanical engineer that is designing a suspension system, right? And in this case, he needs to add a bushing of 8 millimeters, right? That has to have a certain amount of properties, of requirements. So Leo, as the AI that made by and for mechanical engineers, first of all, it finds you parts that are not from, that are from your PLM, that already vetted inside the organization. And then it also shows you vendor parts in order to give you the full perspective. And it finds you the relevant parts that are fit to your best practices and your current CAD design. And here, but this is, for example, a part that Leo found on trace parts, and you can modify and configure it here inside Leo. You don't need to leave Leo. So you see Leo on one screen, your CAD on the other, and this is how you make decisions. And the other thing for us engineers is we need to trust the results that Leo provides because Leo cannot do mistakes. It's an engineering tool. So as you can see here, the engineer is asking, okay, it's a bronze bushing. Now I need to shove it, to press it, right? In heating or cooling for this and that tolerance fit pairs. Tell me what's the force that I need to use. And Leo shows you, right? Shows you the plan, how it's gonna tackle the question, shows you the answer, and this is the important part. Every answer that Leo provides is backed by a reliable source, either from the Bibles or from your documents. So Leo can reference, hey, you need to use this and that force based on Joe's report from 1999 or based on Mill standard. And Leo opens up the right page in the right book, saving you the scrolling time. And you don't even need to run Excel spreadsheets. Leo runs the calculations behind the scenes for you. And in order to be explainable and transparent, it shows you the code that it's used to generate the results. The same for calculations, right? You just run it. You see the formulas in the documentation. Leo runs them, find you the results. And this is how you can make designs, make decisions, find best fit parts, and always with highest confidence that it comes from reliable truths. But Rihanna, if you'd like, I can share with you something which is gonna be the first time ever that we show it. And this is the assembly inspector by Leo AI. So if Leo already knows what's gonna be the next part that you need, or what are your best practices, so the given question is, why Leo can't look at my previous design at the end of the design and inspect it before me, Mr. Engineer, is going to my supervisor, right? So maybe I should make a session with Leo, and this is what he does. Leo is looking at your design, and just click on Leo Inspect, and it tells you what's the level of fit of your parts based on your best practices and inventory. And if the parts are not best fit, it means that there are better parts that fit in terms of geometry and requirements, and they are the standard in my organization. Leo tells you that you can use them. For example, here you mark all the parts that Leo suggests to replace. Leo shows you the level of match in terms of geometry and best practice, and also the number of occurrences of the suggested part. So for example, it tells you here, okay, this is a very popular spring in your organization, try to use it. And you can see the details about it, right? You can see the drawing, you can hit preview, and then Leo shows it to you instead of the current part. And then if you decide to use it, click on another button and it just shows up in your design.